Hello students, this is Bittu Sharma, your physics mentor. Students, first of all, I welcomes you all in the crash course of JEE mains exam by Extramarks. Okay, so in this today's session, students, this is a first physics class of your crash course, and in this class we are going to cover unit dimension and measurement. You all know, like, our exam is very near and we don't have enough time. So first of all, I will tell you how we will proceed in this crash course. Per day, students, daily we will take one chapter, and in that way we will finish our syllabus. Another thing is, like, here instead of, because we have very less time, so in 1 hour we have to finish the entire chapter, unit dimension and measurement. So instead of going in the detailed derivation and the definitions, here I will tell you the quick revision of the concepts, all the formulas which are important for your exam point of view, and with those students we will solve few of the important numericals which we analyze that yes, these questions are in trend, and nowadays JEE is asking these types of questions, and whatever is important, tips and tricks, that and all, everything we are going to give you in this crash course. So again, I'm telling, I'll brush up all the formulas, all the concepts, instead of going in detail the derivation and definitions, and then we will solve numericals which are in trend. Okay, so without wasting any time, students, I will start the session. So you can see here the chapter name is unit dimension and measurement. It is divided, we can divide this into three parts. First will be part of unit, second will be we will discover dimensions, and third we will discuss about the measurements. Okay, so the first thing, students, first thing is units. Okay, so what is units? First of all, we have to understand about the physical quantity. Now, what is physical quantity? Anything which we can measure, is physical quantity. And students, any physical quantity requires, to represent it, it requires two things, where n is the numeric value, and u is the units. Okay, n is numeric value and u is unit. So these two things are required to represent any physical quantity, students. Suppose, let us say I have 5 kg of, you can say, sugar, getting or not? I have 5 kg of sugar, students. So either I write 5 kg of sugar, or I write 5000 grams of sugar. Either I write 5 kg of sugar or 5000 grams of sugar. Both are same. I think you can understand here, quantity is not changing, quantity is same. 5 kg you can say, or 5000 grams you can say, getting or not? But what you can say here, see, this quantity is constant, means what? Any physical quantity, and u, this will always be constant if we are not adding or subtracting any quantity from the from it. Okay, so nu will always be constant, numeric value and unit. From here you can write that n is inversely proportional to u. N is what? N is inversely proportional to u. Now, what is n is inversely proportional to u? As the numeric value increases, then the unit will decrease, or vice versa. Are you getting or not? Here you can see, students, what? This 5 kg, in this quantity, what is numeric value? This 5 is the numeric value and kg is unit. In the same way here, in this 5000 is numeric value and gram is unit. Okay, so as the unit increases, unit becomes what? 5 to 5000, numeric value increases, then you can see here the unit it is decreases, from kg it comes to gram. So I hope you are getting this. Again, please try to understand what we have to study in, what we have to remember in units. Any physical quantity, n u, where n is numeric value and u is the unit, n is inversely proportional to u, and quantity will remain constant. Okay, students, maybe in your regular classes of class 11th, when you studied this chapter, this unit itself took approximately, you can say here, 30 to 40 minutes to understand what is unit, what is physical quantity. There are 7 fundamental units. What are fundamental units? What are derived quantities? What are fundamental quantities? That those and all you had discussed in your regular classes, but here because we have very short period of time, so all those basics I'm not going to discuss here. Okay, like what are fundamental quantities, how many fundamental quantities we have? Total we have 7 fundamental quantities. What are those? Length, mass, time, temperature, amount of substance, getting or not? So all those we have 7 fundamental, luminous intensity, all those we have 7 fundamental quantities. Okay, and units, you have to understand the concept of unit. Any physical quantity can be represented as NU, where N is the numeric value and U is unit. Okay, now based on this, students, I have a question for you. See, in our exam, what type of questions we are getting? You have to understand this. What type of questions we are getting in our exam based on units? No one will ask you what is unit of length, what is unit of time. No, don't think accordingly. Getting or not? The questions which are in trend is the density of material in CGS system is 4 gram per centimeter cube. What they are saying? Density. Density, we know that, students. Formula of density is mass divided by volume. Yes or no? Formula of density is what? It is mass divided by volume. And density is given to us how much? It is 4 gram per centimeter cube. And what they are saying? In a system of unit, the length in a system of unit of length is 10 centimeter and unit of mass is 100 gram. The value of density of the material will be. Students, total we know 4 systems. What are those 4 systems? MK system, CGS system, FPS system and SI system. Getting or not? So the conversion of units in among these systems is very easy and we know all these. Getting or not? Like I ask you, in 1 kilometer how many meters? 1000 meter. In 1 meter how many centimeter? 100 meters. So those are very easy, and in our exam it is very rare that they will ask conversion among all those 4 systems. Now what type of questions we can get in our exam? Students, in question they will say that out of those 4, except those 4, we have another system, and they will fix some standards for that in their system. And here what they are saying, according to their system, according to the new system, what they are saying, the unit of length is 10 centimeter. Okay, unit of length, what they are saying, 10 centimeter means in CJ system 10 centimeter is equal to 1 unit of their system. Yes or no? 1 unit of length of their system. Similarly, what they are saying, 100 gram in CJ system is equal to 1 unit of mass of their system. Okay, so now how we will solve this question, students? Now what they are saying, they are saying that 1 unit of length, they are saying how much? It is 10 centimeter. So from students, here what you can say, 1 centimeter is equal to what? 1 by 10 unit of length. 1 by 10 unit of length. In the same way, you can say that 1 unit of mass is equal to 100 gram. 1 unit of mass is how much? 1 unit of mass is 100 gram. It is given to us. So in that case, students, 1 gram will be how much? 1 gram will be 1 by 100 unit of mass. Yes or no? Unit of mass in the new system. Getting or not? Now we have value of 1 centimeter, we have value of 1 gram, that we will substitute in this and we will get our answer. So density will be what? Density rho is equal to 4 gram per centimeter cube. So you can say 4 in 1 gram, how many unit of mass? In 1 gram, 1 by 100 unit of mass. So 4 into 1 by 100. Here you can write unit of mass. Unit of mass divided by, students, 1 centimeter is equal to 1 by 10 unit of length. So it will be 1 by 10. Now because we have cube, so we will write cube, unit of length whole cube. I hope you are getting this, students. So if you solve this, it is very easy. 4 into 1 by 100 multiply by 1000, basically, because this 1 by 10 whole cube will get reciprocal and the correct answer will be 40. 40 will be the correct answer. So you can say which option is correct. Option C is the correct answer. Like this, students, we can solve these types of questions. I hope you are getting this. Again, try to understand, this is the only question which we are getting based on units. So because we have very short time, so directly I jumped to these types of questions. Okay, Next question students which I have for you is, in a certain system of unit, 1 unit of time is 5 seconds, 1 unit of mass is 20 kg and 1 unit of length is 10 meter. Then 1 unit of power will be how much? Okay, so first of all we'll define what is power. Formula of power is what? Work done per unit time. Formula of power is what? Work done divided by time. Rate of doing work is power. Yes or no? Power is equal to work done by time. Now what is work done students? Work done you can write as force multiplied by displacement divided by time. Now force is what? Mass into acceleration. Mass into displacement divided by time. I hope you are getting this. From here students, now what is acceleration? From here you can write what is acceleration. So it will become mass into acceleration is what? Rate of change of velocity, v by time, yes or no, into displacement s divided by time. And again students, velocity we can write as displacement by time. So it will become mass into displacement by time square divided by time into displacement. So finally how much it will become? It will become mass into displacement square divided by time cube. This we will get the formula of power. What? Mass into displacement square divided by time cube. Now why I did like this? Because I want to convert this power. I want formula of power in terms of fundamental quantities. Because here what they gave unit of time 5 seconds, unit of mass 20 kg and unit of length they gave. Getting or not? Means displacement how much? 10 meter. So they are asking 1 unit of power will be. So 1 unit of power in their system, 1 unit of power in their system students, we will see here. So mass how much they gave? 20 kg. Getting or not? So we will write 20 kg into displacement how much students they gave? 10 meter. Getting or not? 1 unit of length is 10 meter. So 10 meter whole square divided by time cube. So time how much students they gave? They gave how much? 5 seconds. So 5 second whole cube. So this will be the unit of power. If you solve this, how much you will get? 20 into 100 divided by 125. So if you cancel this, 5 4s are 20, 5 25s and 24 4s are 25, 4s are 100. How much we are getting? 16 we are getting. So 1 unit of power in their system is how much? In their system it will be 16 units. Getting or not? So option A will be the correct answer for this question. So like this question students we are getting in our exam. Okay, now the next thing is dimension. Okay, next is what? Dimensions. So first of all students, you have to understand what do you mean by dimension. Again, dimension are the fundamentals of power. Dimension are the powers of fundamental quantities which we can raise to represent any fundamental quantity. Again I am repeating, dimensions are the power of fundamental quantities which we can represent, which we can write to represent a physical quantity. Okay, so that will be dimension. Let us say students, dimension of mass is m, dimension of length is l, dimension of time is t. That and all you know very well. Yes or no? Dimension. Getting or not? Like suppose force dimension, we know dimension of force is what? M L t minus 2. Yes or no? M L t minus 2. So this is the dimension of force. Now how we got this dimension of force? Because we know that force is equal to mass into acceleration. Yes or no? So mass, acceleration you can write as velocity by time. Getting or not? And so m into velocity, what you can write as? Displacement by time into time. Getting or not? So it will become mass into displacement by time square. Now this force you converted in terms of fundamental quantities, and if you want to write its dimension, dimension of mass is m power 1, dimension of displacement is l power 1, and time square, if it will shift in the numerator, it will become time minus 2. So dimension of force will be how much? m1 l1 t minus 2. Like that you can calculate dimension of any physical quantity. Getting or not? So the important concept which we have to understand in dimension is what? The first is principle of homogeneity. Now what is principle of homogeneity, students? Try to understand. Principle of homogeneity says that any two quantities can be added or subtracted. Again I am repeating, any two quantities can be added or subtracted if and only if they have same dimension. Getting or not? For example, let us say A is equal to B plus C. It is written what? A is equal to B plus C. So this equation is only possible. This we can, B and C we can add and subtract only and only if B and C have same dimension. If B and C do not have same dimension, then we cannot add them. For example, simple. If I ask you, can you add 20 kg plus 10 kilometer? How you can add kg and kilometer? No, we can't add, because kg is mass, its dimension is m, okay, and kilometer is length, its dimension is l. So these addition of these two is not possible. Okay, so now we understood B and C should have same dimension. What about A? Do you think A should also have same dimension as B and C? Yes, absolutely correct. A should also have same dimension. How? Because the same equation I can write as A minus B minus C is equal to 0. What I can write? A minus B minus C is equal to 0. Now you can say dimension of A, dimension of B, dimension of C should be same. Should be same. This is principle of homogeneity. Okay students, another, suppose any equation is A is equal to B into C plus D. Now what do you think? Dimension of B and C should be same. Do you think B and C should be same? No, it is not necessary. But the dimension of together BC will be another. BC means dimension of together BC should be equal to dimension of D and should be equal to dimension of A. Means suppose we have any equation in that different terms are there, different terms are adding or subtracting, then all the terms which are going to add or subtract, those terms should have same dimension. Getting or not? This is principle of homogeneity. So from here you can write dimension of A should be equal to dimension of BC should be equal to dimension of D. So this should be there. I hope you are getting this. So this is principle of homogeneity, which is very important for our exam point of view, and we will use this principle of homogeneity in our questions. Okay, another thing students which you have to remember about the dimension is what? First thing, logarithmic function. Logarithmic function. Getting? Trigonometric function. Exponential function. All these do not have any dimension, means their dimension is how much? 0. M0, L0, T0. Getting or not? Their dimension is 0. Either it's exponential function or logarithmic function or trigonometric function, whatever it is there in any equation, their dimension will be how much? It will be 0. M0, L0, T0. I hope students you are getting this. Now the next is application of dimension. Application of dimensional analysis. So how we where we are using this dimensional application? What is application of dimensional? What are the application of dimensional analysis? First, to check, to correct the equation, to check the correctness of equation, to check correctness of equation. Now what is to check the correctness of equation? Let us say I am writing an equation v is equal to u plus 1 by 2 at. Do you think it is correct? Or I am writing v is equal to u plus at, or I am writing v is equal to u plus st. Students, which v is equal to u plus at I am writing here, and here I am writing v is equal to u plus st. Now tell me which equation is correct, first or second? Which one is correct? Definitely first one is the correct answer. We know equations of motion, v is equal to u plus at. V is equal to u plus st is not the correct answer. So students, whether this equation is correct or not, you can check dimensionally. Dimensionally you can check. How? Just now I told you by principle of homogeneity. all the terms which are adding or subtracting should have same dimension. So use the velocity, dimension of velocity, we know that lt minus 1, and dimension of st will be what? Dimension of displacement is l, the dimension of time is t. So here we are getting t, getting or not? So both are not equal, that's why this equation is not correct. But here this equation will be the correct. How? We can check it dimensionally. But there is some limitation, students. What? Dimensionally we cannot check the value of constant. Dimensionally we cannot check the value of constant. Like suppose I am writing s is equal to ut plus 1 by 2 at square, and here I am writing s is equal to ut plus 1 by 4 at square. Now I ask you which equation is correct, first or second? Then definitely you will say, sir, second. First one is the correct answer, because you have already studied in the equations of motion, s is equal to ut plus half at square. This will not be the correct answer. But if you check dimensionally, students, if you equate the by principle of homogeneity, if you want to check this correctness of this equation dimensionally, then what you will find that both the equations are correct, getting or not? So here we have one limitation, that we cannot check the value of constants whether they are correct or not. Okay, so based on this, students, I have one question for you. Okay, I have one question. What they are saying? Planck's constant h, speed of light in vacuum c, and Newton's gravitational constant g are three fundamental constants. Which of the following combination of these has dimension of length? Okay, so what they are saying? They are saying we have Planck's constant, speed of light in vacuum, and Newton's gravitational constant, and we have to find the which of the following combination of these has dimension of light. Okay, so dimension of length. Okay, so how we will solve this, students? What we will think? We will consider, we know there are 7 fundamental quantities, but because in question they are saying consider these three, h, c, and g, as fundamental quantities, so we will consider them itself as fundamental quantity. So let us say L is equal to we'll write in terms of h, c, and g. Okay, but to write the dimensions we should know their powers, getting or not? So let us say their power is x, y, and z. Okay, now the next thing is we should know, students, we should know the basic dimensions of few of the quantities, getting or not? Like very basic, so we know that mass, length, time, current, and temperature, what are their quantities, what are their dimensions, we know very well. But a few are other important dimensions which are in trend, which we can use generally frequently in our questions, like your dimension of Planck's constant, dimension of Boltzmann constant, dimension of you can say here permittivity of free space, dimension of permeability. So these all dimensions are very common, which you should know, getting or not? But if you don't know also, you can calculate dimension by using formulas. So I will tell you one example how you can calculate. If you don't know the dimension of Planck's constant, how we can calculate dimension of Planck's constant, getting? So we know one formula, E is equal to h into nu, where E is the energy, h is Planck's constant, and nu is frequency. From here h you can write as E by nu. Okay, now what is dimension of energy? Dimension of energy is same as dimension of work. Dimension of energy is same as dimension of work. And what is work? Force into displacement. So dimension of force is mlt minus 2 into displacement is L. So how much it will become? It will become ml2 minus 2. So this is the dimension of energy. So ml2 minus 2 divided by nu. Students, dimension of nu is what? Frequency, means per unit time. So dimension of frequency is t to the power minus 1. Okay, so t to the power minus 1. So how much it will come, students? It will come ml2 minus 1. This will be the dimension of Planck's constant. I hope you are getting this. So like this you can calculate dimension of any physical quantity. The main thing is you should know the formula. Okay, so again I am moving towards the question. So dimension of L we have to calculate, dimension of length we have to, formula of length we have to calculate. So let us say it is L. Dimension of Planck's constant, just now we saw ml2 minus 1. So ml2 minus 1 to the power x. Now dimension of speed of light, c is what? Speed of light. So it is a speed only. Dimension of speed is lt minus 1. We all know, yes or no? Meter per second is the unit, and dimension is lt minus 1 to the power y. And dimension of Planck's constant, students, dimension of Planck's constant will be m to the power minus 1 L3T minus 2. And again I am repeating, if you don't know this you can calculate it, but again there are few dimensions which you should know, because we are using those dimensions in our exam frequently. Okay, so m minus 1 L3T minus 2. So if you students write this equation again, so what it will become? It will become m to the power x minus, here it will be power z, m to the power x minus z. Getting or not? If you take all the m together, so m to the power x minus z. L will become L to the power 2x plus y plus 3z. This will be power of L. And t will become t to the power minus x minus y minus 2z. So these are the quantities which we are getting. Again I will write power L is equal to what? M to the power x minus z, L to the power 2x plus y plus 3z, and t to the power minus x minus y minus 2z, minus x minus y minus 2z. So this is power of t which we are getting or not? So if you compare the powers, students, what we will get? X minus z is equal to 0, because here the dimension we have m0 l1 t0. Properly I will write m0 l1 t0. So these are the dimension we are getting. X minus z is equal to 0. From here you can write as x is equal to z. Second we can write as 2x plus y plus 3z is equal to 1, because dimension of L here is 1 and here power is 2x plus y plus 3z. Because x is equal to z, so you can write as 2x plus y plus 3x is equal to 1. So y is equal to minus of 1 by 5x. I hope you are getting. 3 plus 2 5, and it will be 5x is equal to minus y, and x is equal to, or you can write as y is equal to minus of 5x. I hope you are getting this, students. Now next is minus x minus y minus 2z is equal to 0. So again x is equal to z, so you can write as minus z minus y minus 2z is equal to 0, or from here, students, what you can write as minus of 3z minus y is equal to 0. So y is equal to minus of 3z. Okay, so minus of 5x is equal to minus of, sorry, some mistake is there in this, 2x plus y plus 3z. I'll check it. 2x plus y plus 3z. Okay, and minus x minus y minus 2z. Okay, minus x minus y minus 2z. So it will be, students, 2x plus 3x is equal to 1, 5x is equal to minus 1 minus y. Here it's wrong. 5x is equal to 1 minus y, and you can write as x is equal to 1 minus y by 5. Okay, and students, here what you can do, x is equal to minus z minus y minus 2z minus 3z minus y is equal to 0. So y is equal to minus of 3z, or you can write z is equal to what? Y by minus y by 3. Getting or not? Z is equal to what? Minus y by 3. Z, y will shift there, so plus y minus y by 3. Correct. Okay. Now students, x and z we are getting both the values. Will substitute in first equation. X is equal to z. So how much we'll get? 1 minus y by 5 is equal to minus y by 3. If you solve this, students, 3 minus 3y is equal to minus 5y, and it will become minus 2y is equal to 3. So y is equal to minus of 3 by 2. This we are getting value of y. If we will substitute here in z, so how much we will get? Z is equal to minus of 3 by 2 divided by 3. So it will become minus 1 by 2. How much it will become? 1 by 2. In the same way, x will also be 1 by 2. So this values we are getting, because x is equal to z. So if z is 1 by 2, x is also 1 by 2. So these values we are getting, students, and if you substitute these values in the dimension of L, so dimension of L was what? H to the power x, and what was there? C to the power y and g to the power z. C to the power y, g to the power z. So how much we are getting? L, h to the power 1 by 2, c to the power minus 3 by 2, and g to the power 1 by 2. Means it will become how much? Again, if we will solve this, so it will become L is equal to HC under root divided by C to the power 3 by 2. Getting or not? So you can see which option is correct. HC under root divided by HG under root, HG under root divided by C to the power 3 by 2. So option A will be the correct answer for this question. So remember this thing, students, because here I am trying to explain you, so I have to write each and every step. But if you solve this question by yourself, you can solve this question in a very short period of time. Another type of questions which they can ask based on dimension, students, what in a formula x is equal to 5yz square, where x and z have the dimension of capacitance and magnetic field respectively. What is dimension of y in SI system, SI units? Okay, so they are saying what it will be dimension of y. What equation is given to us? X is equal to 5yz square. Now what is x, students? X is the capacitance, and dimension of capacitance we have to calculate. How? Now we can calculate dimension of capacitance. We know that C is equal to what? Q by V. Yes or no? Where C is equal to Q by V. C is equal to Q by V. Getting or not? So now what? Q, the dimension of Q is 80, and dimension of potential difference we can calculate how? Work done per unit charge, W by Q. Getting or not? So like this we can calculate dimension of capacitance. So dimension of capacitance directly I am writing here. What will be? It is M minus 1 L2 T to the power 4 A to the power 2. This is dimension of capacitance is equal to. Students, here we will not consider 5 because we are calculating only the dimension, and already I told you in dimensions we cannot calculate the exact value of constant. Now dimension of y we have to calculate, and dimension of z. Z is what? Z is the magnetic field. And what is dimension of magnetic field? It is M L0 T to the power minus 2 A to the power minus 1. This is dimension of z. Again, and power square. Because why? Because here we have z square. So remember this thing, because I know all these dimensions, so I am telling you, if you don't know, you can calculate it by using formulas. What will be dimension of y, students? Now in that case you can consider dimension of y will become m to the power it will be 2. Getting or not? M to the power 2 and m to the power minus 2 L to the power 2 T to the power, here it will come T to the power 6 and A to the power how much? Sorry, 2 nahi, it is I'll write properly, M minus 1 L2 T to the power 4 A2 divided by this, M will come down, so M to the power 2 L to the power 0 T to the power minus 4 A to the power minus 2. So if you solve this, how much will get? M to the power minus 3, okay, and L to the power 2, okay, and T to the power 8 and A to the power 4. So this will be the correct answer for this question. Getting or not? So here it is minus 2. So this will be minus 2. So which option is correct? You can say option C will be the correct answer for this question. So like this, students, you can solve these types of question. Another is, again, see one more thing, whatever questions I am taking here in this session, most of the questions are from your previous year, previous or last few years JEE mains exam. This question also belongs to your JEE exam only. Let L, R, C and V represents the inductance, resistance, capacitance and voltage respectively. The dimension of L by RCV. L by RCV, where L is the inductance, R is resistance, C is capacitance and V is the potential difference. Getting or not? So this is given to us. We have to calculate its dimension. Dimension will be what? Okay. So the first way to solve this question is what? The general way. First you write the dimension of inductance. If you know, if you don't know, you have to first calculate dimension of inductance by formula. Then you write dimension of resistance. Then you write dimension of capacitance. Then you write dimension of voltage in this formula, and then you solve it. Getting or not? So students, it is going to take more time. Now how we will solve this question within a very short period of time? Try to understand here. What students, have you ever seen the term L by R? Getting or not? L by R, inductance by resistance. L by R, what is L by R? L by R is nothing but, I think if you have studied in alternating current rate, growth and decay of current, so there you saw this term L by R, and it is nothing but time constant tau. Getting or not? So L by R is time constant tau, and its dimension will be what? Its dimension will be T. Okay, now what is this CV? CV is nothing but Q. Getting or not? Because we know that C is equal to Q by V. So Q will be equal to what? CV. So this L by RCV, you can write as tau by Q, where tau is the time constant and Q is the charge. Okay. Now dimension of tau is, students, how much? It is T only. And dimension of charge, because we know that electric current I is equal to Q by T, rate of flow of charge. So from here Q you can write as IT, and I is A, time is T. Okay, so Q, dimension of Q is equal to AT. So you can write as Q as AT. Okay, so T and T will get cancelled, and dimension of L by RCV, how much we are getting? We are getting A to the power minus 1. Option C will be the correct answer for this question. I hope you are getting this, students. Next, what type of see, these all are different types of questions. Don't think like what we are doing here, we are revising our concepts with the numericals so that we can save our time in solving numericals. The force of interaction between two atoms is given by F is equal to alpha beta exponential minus x square by alpha kt, where x is the distance, k is Boltzmann constant, t is temperature, and alpha and beta are two constant. The dimension of beta is. So how to solve this question, students? The equation which is given to us is F is equal to alpha beta exponential function e to the power, you can write as minus x square divided by alpha kt. Okay, now already when I started dimensions, I told you that exponential function do not have any dimension. Getting or not? Remember this thing, exponential function do not have any dimension, means dimension of x square divided by alpha kt is how much? It is m to the power 0. Dimension of this is how much? It is m to the power 0, L to the power 0, and t to the power 0. So this is dimension of minus x square by alpha kt. Now what is x here? X is the distance, k is Boltzmann constant, and t is the temperature. From here, students, we can calculate value of dimension of alpha. Okay, so as of now leave this minus, because again we are not in dimension, we cannot calculate the value of magnitudes. From here, students, you can write as alpha dimension of x square. Dimension of x square, x is length, it will be L to the power 2. Alpha is what? Alpha is the constant, so its dimension we don't know. Dimension of k, Boltzmann constant, so dimension of k is, students, remember this thing, you have to remember m L2 t minus 2 k minus 1. This is dimension of Boltzmann constant, so I will write here m L2 t minus 2 k minus 1. This is dimension of Boltzmann constant into t. T is the time. Getting or not? Sorry, t is the temperature, so it will be k. Okay, so this should be equal to m0 L0 t0. Now if you substitute, if you again solve this, so what we will get? That dimension of alpha, how much we are getting? It will be m to the power minus 1 L to the power, so again I will write L to the power m to the power minus 1 m to the power minus 1 L to the power how much, students? See this, so it will be L to the power 2. If it will shift L to the power 2, L to the power 2 will get cancelled, and t to the power minus 2, if it will shift in numerator, it will be t to the power plus 2. So L to the power 0 and t to the power plus 2, and k, students, k you can see here, k minus 1 and plus 1 will get cancelled. So this will be the dimension of alpha. Dimension of alpha is what? M minus 1 t2. Now what? We have to calculate dimension of beta in our question, but equation of force, what is given to us? Force F is equal to alpha beta exponential function, and here some term is given to us minus x square divided by alpha kt. Getting or not? Now students, again you have to consider this is dimensionless. This complete is what? Dimensionless. Means dimension of force should be equal to dimension of alpha beta. Dimension of force should be equal to dimension of alpha beta. I hope you are getting. Now dimension of force by principle of homogeneity, yes or no? But so dimension of force will be mlt minus 2 Dimension of alpha already we have calculated, m minus 1 t2, and dimension of beta we have to calculate. So from here we can get our answer. Dimension of beta will be equal to m to the power 2, l to the power 1, and t to the power minus 4. This will be the correct answer. I hope you are getting m to the power 2, l to the power 1, t to the power minus 4. Option B will be the correct answer for this question. Okay students, now the next concept is error analysis. Yes or no? Next concept is what? In measurement we have to study two things. In that the first one is error analysis. Okay, so students, again, what is error? If we are measuring any quantity, if we are measuring any quantity by any device, so there may be some we cannot 100% sure that whatever length or whatever quantity, whatever magnitude we have measured, it is 100% correct. Always there is some error in that, getting or not? So that error we have to here identify. The first error is what? Absolute error, getting or not? Absolute error, what? How we will calculate? What we will do, suppose we have to measure length of any length of this scale. So what we will do, we will calculate its length again and again, yes or no, number of times. So x1 we will calculate, then x2 we will calculate, then x3 we will calculate, then x4 we will calculate, getting or not? And then we will take its mean, getting its actual length. Let us say first we have calculated its actual length, then x minus x1, x minus x2, x minus x3, getting or not? These and all will be absolute error. I will not waste more time on these theoretical part. What is absolute error? What is mean absolute error? Mean absolute error is nothing but the mean of all the absolute errors. Mean of all the absolute errors, delta x1 plus delta x2 plus delta x3 and so on, divided by n plus delta xn. This is mean of absolute errors, getting or not? So this we will use in our numerical. Now what is fractional error, students? Fractional error is nothing but suppose we are measuring any quantity delta x divided by x. This is fractional error, getting or not? Delta x divided by x will be the fractional error, and if you want to calculate its percentage, so it will be delta x by x into 100, getting or not? So like this we can calculate errors. Like this we can calculate errors. I will directly jump to the questions. So first I will tell you about combination of errors, and I will directly jump to the questions. Then we will feel what is error, and we will get to know that what type of questions we are getting on errors. Okay, now combination of errors means first of all we have to understand if any two quantities we are adding or subtracting. So first I will come for addition. Suppose we have any quantity, let us say x is equal to, for example I am taking, let us say x is equal to 2 plus minus 0.01, okay, and y is equal to how much? Let us say 4 plus minus 0.02, getting or not? Then what will be x plus y? What will be x plus y, students? Remember this thing, errors will always add. Again I am repeating, errors will always add. So x plus y will be, students, what? It will be 4 plus 2, 6 plus minus 0.01 plus 0.02, it will be 0.03. So this you have to remember, what? This error here, whether it is addition or subtraction, whatever it is, but errors will always add. In the same way, students, if we will see for subtraction, the same example I will take. X is equal to 2 plus minus 0.01, y is equal to 4 plus minus 0.02, then x minus y will be what? So x minus y, students, first of all what we will do, this we will subtract 2 minus 4, yes or no? So 2 minus 4 will be minus 2, or if because these are lengths, so better we will calculate y minus x. Y minus x will be, we will get 4 minus 2 will be 2 plus minus, now what do you think, 0.02 minus 0.01 or plus? Again I am repeating, what? These errors will always add, getting or not? Errors will always add, so it will become 0.03. This will be the correct answer for this example. I hope you are getting this. So this is combination of error. Now third is multiplication. Third one is multiplication. Let us say, students, length of any rectangle is given as 2 plus minus 0.1 and breadth is given as 3 plus minus 0.2. So what will be its area? Getting or not? Simple, we have to calculate L into B, length into breadth we have to calculate. So how we will calculate length into breadth? The simple thing, first of all, we will multiply these 3 and 2. So 3 and 2 will be we will get 6. Now plus minus what will come here in terms of error? So in multiplication, what you have to do? Delta multiplication, delta L into B divided by L into B is equal to delta L by L plus delta B by B. So this you have to remember, students, what this is the you can say this is the way how we will calculate error in case of multiplication, and the same will be there in case of division also. What is delta L into B? Delta L into B is error in length into breadth divided by what is over original length into breadth is equal to delta L by A, error in length divided by original length, plus delta B by B, error in B divided by B. Okay. So division also, students, if you want to calculate delta L by B, so how you will calculate error? Delta L by B divided by L by B is equal to delta L by L plus delta B by B. So this is the way for what? For division. For multiplication and division, it is approximately same, as well as for addition and subtraction. Okay. The last one is in case of powers. Okay. Suppose we have any quantity x is equal to a square b cube. Okay. So how we will calculate dimension in errors in x? So what we will do? We will delta x by x. Delta x by x is equal to, power will come in front, 2 into delta a by a plus 3 into delta b by b. I hope you are getting this. Again I am repeating what we will do here. Whatever power we have, that power will come in front. 2 will come in front of a. Twice of delta a by a plus thrice of delta b by b. Like this we can solve questions based on dimensions. So here I have one question for you. A piece of material M with mass 40 gram and error 0.4 gram and value 10 centimeter cube with error 1 centimeter cube, the density of material. So what they are saying, students, mass how much we have? We have 40 gram plus minus of 0.4 gram. Yes or no? This error is how much? 0.4 gram. So 40 plus minus 0.4 gram, and volume how much we have? Volume we have 10 plus minus 1 centimeter cube. 10 plus minus 1 centimeter cube. So mass and volume is given to us. They are asking what will be density. So density, students, we know density is what? Mass by volume. Okay. So now it's the case of division. How we will calculate it? How we will calculate it, students? First of all, we will calculate the density. Mass is how much? Mass is 40. Volume is how much? It will be 10. It is 10, so it will be 4 gram per centimeter cube. So this is actual value of density. Now we will calculate the error. How to calculate error in density, students? Again, density is what? Mass by volume. So for case of division, I already explained, delta rho by rho is equal to delta m by m plus delta v by v. Getting or not? Now delta rho, error in density we have to calculate, into rho, divide by rho. Actual density is how much? 4 is equal to delta m, error in mass is how much? 0.4 divided by mass is how much? 40, plus the error in volume is 1 divided by actual volume 10. Getting or not? So from here, students, you can calculate here what? It will be delta rho by 4 is equal to, if you take LCM as 40, so 0.4 plus 4. So it will become how much? 4.4 by 40. So delta rho by 4 is equal to 4.4 divided by 40. means delta rho is equal to 4.4 divided by 10, which is 0.44. So error in density, how much we are getting? 0.44. 0.4 you can say here 4.4, if it is not wrong. LCM is 40, 10, 4, 4.4. Yes, so 4 point something mistake we did, I think 0.4 gram. So 40 by 10, yes or no? So 4 gram per centimeter cube. Delta rho by 4 is equal to 0.4 by 40, yes, divided plus 1 by 10. So it will be 0.4. It is not 0.4 gram, actually it is 4 gram. No? It is actually 4 gram. So here it will be plus minus 4 gram. So it will be 4. Getting or not? So here also it will be 4. 4 plus 4 we will get how much? 8. Okay. 4 plus 4 we will get 8. So it will be 8 divided by 40. Okay. So delta rho will be what? It will be 8 divided by 10, which is 0.8. I hope you are getting. Now students, density we can write as density is equal to how much density we got here? We got 4 gram per centimeter cube. So 4 plus minus 0.8 gram per centimeter cube. This will be the correct answer for this question. So you can say option A, 4 plus minus 0.8 is correct answer. Okay. Another question based on error which we have is, in an experiment 4 quantities A, B, C and D are measured with the percentage error 1, 2, 3 and 4 respectively. The quantity P can be calculated as. So students, P is given A cube B square divided by CD. Okay. Now how we will calculate the percentage error in P? So remember, percentage error in P, delta P divided by P into 100 is equal to, again I told you what powers will come in front, into percentage error in A. Percentage error in A plus power will come in front, percentage error in B. Now if this C is in denominator, do you think that it will be minus? No. Again powers will always add, delta C by C into 100 plus delta D by D into 100. Now all the values are given to us. Percentage error in P we have to calculate is equal to 3 into percentage error in A is how much? It is 1% plus 2, this 2, yes or no? Delta B by B into 100, percentage error in B is 2% plus percentage error in C is 3% plus percentage error in 4 is how much? It is 4%. So if you solve this, how much we are getting? 3 plus 4, 7, 7 plus 7, 14. 14% is the correct answer. So percentage error in P will be how much, students? It will be 14%. Okay. The next concept in measurement is, students, what? Significant figure. For very important for your exam point of view. Okay. So how we can calculate the significant figures, students? Again, instead of going definition what is significant figure and all, I'll directly tell you the rules how you can calculate the number of significant figures. The first thing is, all non-zero digits are significant. Suppose I have a quantity 2234.65. In this, how many significant figures are there? Students, 5 significant figures are there, because all the values here, all the digits are non-zeros, and non-zeros digits are significant. Okay. All zeros between two significant figures are significant. Suppose I am writing 205.06. So in between any two significant figure, all the zeros are significant. You can see here, this 0 and this 0 is in between two significant figures, 2 and 6. So total significant figure will be how much? 1, 2, 3, 4, 5. Total significant figure will be how much? It will be 5. Getting? Ending zeros, it should be after decimal with ends are significant. Now what they are saying? Ending zeros, like suppose if it is after decimal are significant. Let us say I am writing 20.00. Now how many significant figures are there in this? There are 4 significant. Let us say I will take 23.00. Now how many significant figures are there in this? There are 4 significant figures. Why 4 significant figures? Because remember, if the zeros are after decimal, If the zeros are after decimal, then we will consider them as significant figures. Okay, so again students, I have example 20.040. How many significant figures are there? Do you think this 0 will be significant or say insignificant? You can say here, sir, this 0 is before decimal, so it will be insignificant. But see, rule number 2, all the zeros in between significant figure will be significant, so this 0 will also be significant. Okay, the next rule students, what? Initial zeros are insignificant. Initial zeros, let us say I am writing 0 0 0 2 5, so this points to, so these 3 zeros are insignificant. In this, only these 3 digits are significant. Only these 3 digits are significant. Okay, these 3 digits. Okay, now power of 10 are significant. Suppose I am writing 2 into 10 to the power 6, so this 6 and this power of 10, this is again insignificant. Another students, pure number constant have infinite significant number. Like suppose I am telling Reynolds number, yeah, Planck's constant, yeah, refractive index 1.5. So this 1.5 you can write as 1.5000. So all these constants or any pure number, these all have always infinite significant numbers. Infinite significant numbers. Okay, I hope you are getting this students. Next we have one question for you. The respective number of significant figures for the number 20.023, 0.0003 and 2.1 into 10 to the power minus 3 are. So students, this question is also from your IIT JEE mains, which year I forget, but this question also belongs to your exam. You can see how easy questions also they are asking. So in this, how many significant figures are there? 0.023. So first of all the non-zeros are significant, so 3 are, getting or not, and these 2 are in between 2 significant figures, so these 2 zeros will also be significant. So total number of significant figures are 5. Now 0.0003, getting or not. Now how many significant figures are there in this students? How many significant figures are there? All the initial zeros are insignificant, so only one significant figure is there in this. And 2.1 into 10 to the power minus 3, so power of 10 is insignificant, means we have only 2 significant figure. So the correct answer will be 5, 1 and 2. 5, 1, 2 will be the correct answer for this question. So like this students, you can solve questions based on significant and insignificant figures. So here I am going to end this session students. Whatever doubts you have, you please ask. Practice numericals as much as possible. Here whatever concepts of unit dimension and measurement are there, I explained you. We revised each and everything. We solved at least 2 questions based on every concept. Now you have to solve questions, then only you will get success. Thank you very much students.